And welcome back to the channel. So we're solving September 9 question today, and then it's spiral matrix 4. I believe we did have a spiral matrix 2 question last month in August, and then I did make a video. So if you want to check some variation of the question, and yeah, you just feel free to look at that video. But this question is actually more similar than a walking robot simulation that I'll put a link that attached to that video. But just a head up, the audio is kind of bad, but you can just see how similar it is to approach this two question. So let's actually read this question. So you're given two integers m and n, which represent the dimension of matrix. In this case, m is actually the number of rows, and n is the number of columns. And then you're also given the head of a linked list. So your task is starting from top left of the matrix. Normally we call that 0, 0 for the coordinate. And we just want to do it in a spiral order, in a clockwise order, starting from that top left, and then fill up the thing. So the constraint maybe is limited that you will have enough value in the head given to you to put it, but so that means it wouldn't get over. So maybe if given m by n is 15 block, you wouldn't be given 17 or above. But in the case that you have less than the m by n, then you just fill the remaining empty space by -1, and then you just return the generated matrix. So in this example, you see this is the head. We start filling in 3, 0, 2, 6, 8, and then we hit the end of that row. Then we start doing spiral way. We fill out 1 and we fill out 7, and then we change the direction, filling in until we hit a 0 right here, which is the end of the linked list, and we just fill the remaining, which is -1. All right. So spiral matrix 4 questions. This is whatever it is. So we actually want to figure out how we making a turn, right? How do we make sure that we know when is it to turn, right? Like, how do we know that we're not going straight until this point, but we make a turn right here? So as I said, for the walking robot simulation problems, if you haven't solved that problem, I strongly recommend looking at that question first, actually, and see if you can figure out something like the directions, and then try to do this question. All right, so we have a direction. 0, 1 means that we're moving this way, and then 1, 0 means we're moving downward, and then this is left, and then this is up. So we can see that we're moving left first. Oh, right, I'm sorry. Moving right first, and then we're actually going down, and then we're going back to left, and then we're going top. So what exactly is the point that we know? Well, we know that we need to turn. So it's either you go out of bound, maybe this is n, right? Yeah. When we know we go out of bound, or we know that something we are going into, let's say this point, because imagine we just make like a travel around this edges, right? We might just keep spiraling in the outdoor, right? Like this outside edge, the outside layer, right? So how do we know that when we come back here, we need to do to the inner layer? Is that when we check the next element, following the direction, and then we see, hey, this is actually not -1 anymore. If this is not -1, then we know that yeah, we know this has been filled, so we need to switch the direction, because actually the constraint told you that the node dot value will be in between 0 to 1,000. So that's never change that. If this thing is not -1, and then it will be filled, right? Wait, let me rephrase it. So if that thing is not -1 anymore, it's guaranteed that it has been filled with some value, because we will never fill a -1 that's in the linked list, because the linked list will never be a -1. All right, so that's cool. So If something is not -1 anymore, it means that spot has been taken, and then we just want to switch to another direction. So this is let's just do the code and see if things click and make sense. Well, 150. Okay, 125 is good. All right. So this is just how you initialize a 2D array. If you have been following this account or this channel, you see how I initialize 2D array. But if this is the first time here, this is how normally we do a 2D array. So initialize whatever value you want to put in each box, and then we just do the row, the column first. So we multiply this by the column. So we make, so let's say the n is 5. So we already done making one row of n columns, and then we can do for dash in range m. So this is for the rows. And then as I said, we can have this direction thing. So maybe I can just copy this. And then we can have the direction. And then have a current direction to be equals to 0, because this actually is an array, is zero indexing, means we're going right in the first place. And then I can have I equals to 0 and j equals to 0 to start. And I actually like just declare new pointer when it comes to linked list, current equals hat, but feel free just use hat. I think you don't need to go back to the hat anyways, so you can just modify the hat to be like hat.next, but I just like to keep the hat still there, so I just use a current. So while current, so I will set result matrix I and j equals to the current dot value. And then similar to the robot problem, I would make new I equals to I plus directions at the current direction. So this tell you which index you need to look at for directions. Let's say now 0, and then we want to look at this one because this is the x for it. And then for new j, then this will just be j plus everything same, but look at the second value because it's like the xy coordinate. So first one is for I, the second one is for j. And now it comes to checking the condition. We can set if new I is less than 0 or greater equals to m, or our new j is less than 0 or new j is greater equals to n, or we already seen the thing right there, it's not -1 anymore. So the result at coordinate new I, new j is not equals to -1. Then we can set the current direction to move on to the next one. So it means we're switching direction. Why I can just use plus equals 1 is because there are only 4 of them, right? So it could possibly go out of bounds. So we want to do the current direction plus 1 and then mod 4. If it's done, then we know that our new I will be in moving to a new direction. So we just want to plus equals that one. And why we're doing that is because we just want to move to the next one. So we can get ready while we're entering the while loop again. We can just set that new position to be a new current dot value. So here we can just make I plus equals the directions of the current direction and then the first value. So we do the same thing for j. And lastly, before exiting the while loop, we just want to move the current to be the next value. So current equals to current.next. So before we run, we need to make sure we actually return the result. So this is it. We can run it. then we can submit it. So instead of just running around, we actually just run the current time, which is the head, the number of head time. That's actually not very true if we set this head to be the length of it. We actually the max of the runtime probably should be actually the result setting, because we're setting a 2D array but of size n by n. So even though we not the length of the head could be less than n by n, but we still has n by n because all those remaining length that the current or like the head doesn't have will already be filled out by -1. So that's the runtime is going to be of n squared. And if you, so some people argue that space complexity shouldn't include whatever you're going to return. But in this case, we actually create a result, a 2D matrix, which is an n squared memory. So if you've been asked about space complexity, I will say that's of n squared for the result. But other than that, we actually not creating extra spaces besides this direction would took probably of 8 or of 4 space. So yeah, this is just be the runtime and the space complexity. I found out that I sometimes didn't explain about this. So if you see something and really want to point out the space or runtime complexity, just feel free to point out. I'll see you guys in the next video.